On this Chevrolet Silverado 2500 with the V8 6.6L DSL turbo application, P0113 is an intake air temperature sensor 1 circuit high voltage code. In plain terms, the control module may be seeing the intake air temperature signal in a way that often looks like unrealistically cold air. The truck may turn the cooling fan on, may show a service emissions or exhaust fluid message, and engine operation can be affected depending on what else is going on. Broadly, possible fault areas include the sensor signal circuit, the low reference side, harness and connector issues, the multifunction intake air sensor, and less commonly the control module. This code sits in a larger group of related intake air and pressure sensor diagnostics, so if other codes are present, check what they mean first, but keep this diagnosis focused on P0113. Before testing, understand the circuit. The control module input has internal resistance tied to 5 volts. The intake air temperature element changes resistance with temperature. Low temperature produces high resistance, shown as 1.2 kiloohms at 40 degrees Celsius, and high temperature produces low resistance, shown as 109 ohms at 120 degrees Celsius. As a scan data reference, the parameter normal range is from -39 to 130 degrees Celsius, and the scan tool display range is between -40 and 150 degrees Celsius. Typical fault data shows the signal at 150 degrees Celsius for a short to ground, and at -40 degrees Celsius for an open signal or a signal short to voltage. An open low reference path can also show -40 degrees Celsius. Internal control module or component damage may occur if the circuit shorts to B+. Start with the basic system checks before getting deep into this code. Then follow a structured diagnostic approach and make sure the general diagnostic categories make sense for the fault you are chasing. If another code changes the direction of the diagnosis, deal with that first, instead of forcing this path. For P0113, the code is allowed to run when the ignition is on or the engine is running for greater than 1 second, and then it runs continuously after those conditions are met. The setting logic for this code is IAT sensor 1 colder than -60 Celsius, -76 Fahrenheit for greater than 4 seconds. Treat those as the monitor gates and the fault formula, not as a repair by themselves. With the ignition on and the vehicle in service mode, look at the scan tool value for IAT sensor 1. It should be -39 to 149 degrees Celsius, -38 to 300 Fahrenheit. If it is outside that range, move into circuit testing. If it is inside the range, keep watching the value and make sure it does not spike or drop out. While watching the parameter, wiggle the harness and connectors at the B75C multifunction intake air sensor and at the K20 engine control module. If the value spikes or drops out, repair the wiring, terminals, or connectors as needed. If the value stays stable, reproduce the operating conditions, including the captured conditions if they help duplicate the fault, and confirm whether P0113 resets. If it does not reset, the check is okay at that time. If it resets, move to circuit testing. For circuit testing, turn the ignition and vehicle systems off. It may take up to 2 minutes for all vehicle systems to power down before an accurate ground or low reference continuity test can be made. Disconnect the B75C multifunction intake air sensor. Test for less than 5 ohms between low reference circuit terminal 3 and ground. If it is 5 ohms or greater, disconnect the proper connector at the K20 engine control module and test end-to-end on that same low reference circuit. You want less than 2 ohms between low reference circuit terminal 3 at the component harness and the other end of the circuit at the control module harness. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If it is less than 2 ohms, the diagnostic path points to the K20 engine control module. If the low reference test is less than 5 ohms, turn the ignition on with the vehicle in service mode and verify the scan tool shows IAT sensor 1 colder than -39 Celsius, -38 degrees Fahrenheit. If the scan tool shows -39 Celsius, -38 degrees Fahrenheit, or warmer, turn the vehicle off, disconnect the K20 engine control module, and test for infinite resistance between signal circuit terminal 1 at the component harness and ground. If the resistance is less than infinite, repair the signal circuit short to ground. If it is infinite, the diagnostic path points to the K20 engine control module. If the scan tool did show colder than -39°C, -38°F, connect a 3-amp fuse jumper wire between signal circuit terminal 1 and low reference circuit terminal 3. Now the scan tool should show IAT sensor 1 warmer than 149°C, 300°F. If it is 149°C, 300°F or colder, turn the vehicle off, remove the jumper, disconnect the K20 engine control module, turn the ignition back on in service mode, and test for less than 1 volt between signal circuit terminal 1 at the component harness and ground. If it is 1 volt or greater, repair the signal circuit short to voltage. If it is less than 1 volt, turn the vehicle off and test for less than 2 ohms end-to-end between signal circuit terminal 1 at the component harness and the other end of the circuit at the control module harness. If that resistance is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, the diagnostic path points to the K20 engine control module. If the jumper test does drive the scan tool warmer than 149°C, 300°F, test or replace the B75C multifunction intake air sensor. For component testing, keep the ignition and vehicle off and disconnect the B75C multifunction intake air sensor connector. Test between signal terminal 1 and low reference terminal 3. The resistance should be 54 to 54,224 ohms. If it is outside that range, replace the B75C multifunction intake air sensor. If it is inside that range, compare the value to the temperature versus resistance data for the actual intake air temperature. If those values are not available in the bay, pause and do not guess the missing temperature to resistance values. If the value is not in the specified range for temperature, replace the B75C multifunction intake air sensor. If it is in range, test for infinite resistance between each terminal of the component and the component housing. If either terminal shows less than infinite resistance to the housing, replace the B75C multifunction intake air sensor. If both are infinite, the component checks OK. After completing the repair, verify the repair and confirm the code stays gone. Keep this separate from the category-specific circuit tests. Clear the fault, reproduce the operating conditions, and make sure P0113 does not reset. If the service emission system or service exhaust fluid system message is displayed, perform the reducted system tamper service bay test only under that condition. Performing that test will clear the driver information message for the applicable system. The takeaway on P0113 is simple. Prove the scan data first, stress the harness, then separate a low reference fault, a signal circuit fault, a sensor fault, and a control module path with controlled circuit tests. Do not skip the power down time, do not guess at missing temperature resistance values, and verify the code stays gone under the conditions that originally set it. For more diagnostic training, visit stepdiagnostics.com.